Hello students, in this session we will be dealing with the next topic, that is rectification. So what is this rectification? It is nothing but the process of converting AC voltage or current into pulsating voltage or current. So why do we need to convert this AC voltage or current into pulsating DC voltage or into DC and current? There are many electronic goods where DC is required. So we need a circuit which converts that AC to DC. So easily available source is AC, and we need to convert this AC source into DC in order to give supply to many of the electronic goods. The best example is a mobile phone. Mobile phone ನಲ್ಲಿ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇರುವಂತ battery, that is a DC battery. So in order to charge that battery we need DC supply. So in order to charge that battery we need a DC supply ಅಂತ ಹೇಳಿದಾಗ whatever the source is coming through the plug points is pure AC, and that AC has to be converted into DC, which charges the battery of our mobile phone. So where is the converter? Where is the circuit which converts that AC to DC ಅಂತ ಹೇಳಿದಾಗ ಮೊಬೈಲ್ ಚಾರ್ಜರ್ ನಲ್ಲಿ ಏನು ಅಡಾಪ್ಟರ್ ಅಂತ ಇರುತ್ತೋ, in that adapter will be having a circuit which converts AC into DC, and that DC will helps in charging the battery of a mobile phone. So that is the topic of this session, that is rectification. So this is nothing but the process of converting AC voltage or current into pulsating DC voltage or current. AC ಅಂತ ಹೇಳಿದಾಗ it is nothing but a sinusoidal waveform. Sinusoidal waveform ಅಂತ ಹೇಳಿದ್ರೆ it will be having both positive as well as negative waveform. These are the positive cycles, positive half cycle, and this is a negative half cycle. Pulsating DC ಅಂತ ಹೇಳಿದ್ರೆ DC ಅಂತ ಹೇಳಿದ್ರೆ if I am going to consider this as a time, this as nothing but the voltage or the current, DC ಅಂತ ಹೇಳಿದಾಗ I need a constant line. DC, it is nothing but a straight line. But when we are going to use this rectifier, we are going to get the output like this pulsating DC ಅಂತ ಹೇಳಿದ್ರೆ both the positive as well as the negative half cycles will be in one direction. Here according to this diagram, both are in the positive direction. ಅದೇ ಥರ ನೆಗೆಟಿವ್ DC ಕೂಡ ಸಿಗುತ್ತೆ. ನೆಗೆಟಿವ್ DC ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಥರ. So these are nothing but the pulsating DC signals. So rectification is nothing but the process of converting this AC voltage or current into pulsating DC or pulsating DC voltage or current. Okay. So ಇದರಲ್ಲಿ ನನಗೆ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ರೆಕ್ಟಿಫೈಯರ್ಸ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ಬರುತ್ತೆ. ಒಂದು ಹಾಫ್ ವೇವ್ ರೆಕ್ಟಿಫೈಯರ್ ವಿಚ್ ವಿಲ್ ಬಿ ಡಿನೋಟೆಡ್ ಬೈ HWR and full wave rectifier which will be denoted by FWR. Again, this full wave rectifier is further classified into two types: center typed FWR and bridge FWR. So now let us first see the circuit half wave rectifier. So what is this half wave rectifier? Half, here this half wave rectifier is nothing but again a circuit which rectifies only one half cycles, either the positive half cycles or the negative half cycle. The remaining half will be rectified, in the sense the remaining half of the cycle will be removed completely. So a rectifier circuit which rectifies only one half cycles of the input AC wave is called as half wave rectifier. And for that we are going to use diode as one of the major component in converting the AC input into the pulsating DC. So this is the circuit diagram what we are going to use in order to convert the AC supply into the pulsating DC. So here this is the diode what we are going to use. This is the AC supply, and here we are going to use a transformer, that to a step down transformer. Whatever the AC supply, AC signal we are giving to the input or to the primary of the transformer, that will be stepped down, that or that will be reduced to a larger extent, and that will be given to the diode what we are going to use. So here AC supply will be having both positive as well as negative half cycles like this. Let us talk about only the positive half cycle first. Whenever the positive half cycle is appearing across the secondary of the transformer, that is to these two ends, The terminal A will be positive and the terminal B, here let me consider, here they have mentioned it as O, and that terminal will be negative. So in order to turn on the diode, we need to give the biasing, that too in the forward biasing condition. Forward biasing condition anta ಹೇಳಿದ್ರೆ P type must be connected to positive terminal and N type must be connected to negative terminal. Likewise, the terminal, this terminal A is positive anta ಹೇಳಿದಾಗ, this is the anode terminal, this is the cathode terminal, and this is connected to the cathode through the resistor. ಸೊ ಆ್ಯನೋಡ್ಗೆ ಈಗ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಕನೆಕ್ಟ್ ಆಗಿದೆ, ಕ್ಯಾಥೋಡ್ಗೆ ನೆಗೆಟಿವ್ ಕನೆಕ್ಟ್ ಆಗಿದೆ ಥ್ರೂ ದ ರೆಸಿಸ್ಟರ್, ಲೋಡ್ ರೆಸಿಸ್ಟರ್ RL. So the diode starts conducting, the diode will be turned on. The diode turned on ಅಂತ ಹೇಳಿದ್ರೆ, this diode works like a switch, and now in this case it will be acting like a on switch. These are the 2 points of a switch ಅಂತ consider ಮಾಡ್ಕೊಂಡ್ರೆ, and this diode now is acting like a switch, closed switch ಅಂತ ಹೇಳಿದಾಗ these two contacts will be touching with each other. So whatever the voltage that is appearing across the secondary of the transformer, the same voltage will be appearing across the load. So positive half cycles ಏನಿತ್ತು, that entire positive half cycle will be appearing across the load. Now let us consider that negative half cycle is appearing across the secondary of the transformer ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. So negative half cycle appear ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳುವಾಗ, the terminal A will be negative and this O will become positive. In this case, anode terminal is connected to negative terminal ಅಂತ ಹೇಳಿದಾಗ, this diode will be reverse biased. Reverse bias ಅಂತ ಹೇಳಿದಾಗ it will be acting like a open switch. I told you that the diode is nothing but will act like a switch. Now it is acting like a off switch. ಆಫ್ ಸ್ವಿಚ್ ಅಂತ ಹೇಳಿದಾಗ ದ ಕಾಂಟ್ಯಾಕ್ಟ್ಸ್ ಆರ್ ಓಪನ್ ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ RLಗೆ ಯಾವುದೇ ರೀತಿಯಾದಂಥ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ನೌ ದ ಸರ್ಕ್ಯೂಟ್ ಇಸ್ ಓಪನ್ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಡಯೋಡ್ ವಿಚ್ ಈಸ್ ಆಕ್ಟಿಂಗ್ ಲೈಕ್ ಅ ಓಪನ್ ಸ್ವಿಚ್. ಹಾಗಾಗಿ ನನಗೆ ಈ ನೆಗೆಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ ಏನು ಇನ್ಪುಟ್ನಲ್ಲಿ ಅಪ್ಲೈ ಆಗಿತ್ತೋ, ದಟ್ ನೆಗೆಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ ವಿಲ್ ಬಿ ಕಂಪ್ಲೀಟ್ಲಿ ಎಲಿಮಿನೇಟೆಡ್ ಆಟ್ ದ ಔಟ್ಪುಟ್. ಸೊ ನನಗೆ ಬರೀ ಪಾಸಿಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ಸ್ ಮಾತ್ರ ಅಪಿಯರ್ ಆಗುತ್ತೆ, ದ ಎಂಟೈರ್ ನೆಗೆಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ಸ್ ವಿಲ್ ಬಿ ಕಂಪ್ಲೀಟ್ಲಿ ರಿಮೂವ್ಡ್. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಸರ್ಕ್ಯೂಟ್ ವೇರ್ the negative half cycles are rectified. Only the positive half cycles are appearing towards the, or is appearing at the load side. So ನನಗೆ ಈ half wave rectifier ಅಂತ ಹೇಳಿದ್ರೆ, it is nothing but a circuit which rectifies only one half of the cycle, ಎಲಿಮಿನೇಟಿಂಗ್ ದ ಅದರ್ ಹಾಫ್ ಸೈಕಲ್ ಅಂತ ಹೇಳ್ಬೋದು. ಅಲ್ಲ ನನಗೆ ನೆಗೆಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ನ ಇಟ್ಕೊಳ್ಬೇಕು, ಪಾಸಿಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ನ ರಿಮೂವ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ವಿ ಜಸ್ಟ್ ನೀಡ್ ಟು ಕನೆಕ್ಟ್ ದ ಡಯೋಡ್ ಇನ್ ದ ರಿವರ್ಸ್ ಡೈರೆಕ್ಷನ್. ಡಯೋಡನ್ನ ನಾವು ಈ ಥರ ಕನೆಕ್ಟ್ ಮಾಡಿಕೊಂಡ್ರೆ ಪಾಸಿಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ಸ್ ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ಸ್ ಮಾತ್ರ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಕ್ಲಿಯರ್? Now let us move on to the next topic, that is full wave rectifier. So what is this full wave rectifier? Full wave rectifier is nothing but the circuit which rectifies both half cycles of the input AC wave. And I mean to say, ಏನ್ AC input signals ಈ ಥರ ಇರುತ್ತೋ, which contains both positive as well as negative half cycles, half wave rectifier ನಲ್ಲಿ only half of the cycles was appearing across the load. But here in the full wave rectifier, both of the half cycles will be appearing at the load ಅಂತ ಹೇಳಿದ್ರೆ, I'll be getting the waveform either like this or like this. This is the positive DC signal and this is the negative DC signal. And the circuit what we are going to use are of two types. One is the center tapped full wave rectifier and the other one is bridge rectifier. Now let us see the center tapped full wave rectifier. So this is the circuit what we are going to use in order to construct a center tapped full wave rectifier. Here we are going to use two diodes D1 and D2, and the remaining part will remain the same. That is, we are going to use a transformer, but here it is a center tapped transformer. Center tapped transformer and headed. A tapping will be taken from the center of the winding, and by doing so we'll be getting three separate terminals on the secondary side of the transformer. This is one terminal, this is second terminal, and this is the third terminal. Here we are going to use two diodes and the load resistor will be named as RL. So for the positive half cycles, for the positive half cycle of the input AC signal, the terminal A will be positive and the terminal B will be negative, whereas this is a neutral point. ಹಾಗಾಗಿ Here in this case, D1 the anode terminal is this is the cathode terminal, and D2's anode is this, and cathode is this. According to this, D1 will be forward biased whereas D2 will be reverse biased. Forward bias ಅಂತ ಹೇಳಿದಾಗ that diode will be acting like a on switch. Reverse bias ಅಂತ ಹೇಳಿದಾಗ that diode will be acting like a off switch. On switch ಅಂತ ಹೇಳಿದಾಗ this D1 will be short circuited whereas D2 will be open circuited. ಆವಾಗ ನನಗೆ ಈ ಅಪ್ಪರ್ ಪಾರ್ಟ್ ಆಫ್ ದ ಸರ್ಕ್ಯೂಟ್ ಮಾತ್ರ ಉಳ್ಕೊಂಡಿರುತ್ತೆ ಬಿಕಾಸ್ ದಿಸ್ ಲೋವರ್ ಪಾರ್ಟ್ ಏನಾಗಿದೆ ಓಪನ್ ಆಗಿದೆ. So now the current will flow in this direction. A in the diode, diode in the M in the RL in the N in the E neutral point. So the current flows in this direction from M to N, that is from upper region to lower region. Now let us see what happens. So ivaga in this case the positive half cycle is appearing across the load. Now let us see what happens when negative half cycle is appearing at the input side. Negative half cycles anta bandaga the terminal B will become positive whereas the terminal A will be negative. Negative anta ಹೇಳಿದಾಗ here in this case D1 will be reverse bias whereas D2 will be forward bias. So D1 will be acting like a off switch, D2 will be acting like a on switch. In that case ನನಗೆ ಸರ್ಕ್ಯೂಟ್ ಉಳ್ಕೊಳ್ಳೋದು ಇದು ಇದು ಮಾತ್ರ, ಇಷ್ಟು ಮಾತ್ರ ನನಗೆ ಸರ್ಕ್ಯೂಟ್ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಹಾಗಿದ್ರೆ ಕರೆಂಟ್ ಹೇಗೆ ಫ್ಲೋ ಆಗುತ್ತೆ ಅಂದರೆ ಬಿ ಇಂದ ಡಿ ಟು ಇಂದ ಇಟ್ ಇಸ್ ಅ ಜಂಪ್ ಅಂತ ಹೇಳಿದಾಗ ಇಟ್ ಗೋಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಟು ದ ಅಪ್ ಸೈಡ್ ಟು ದ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಆ್ಯಂಡ್ ಫ್ರಮ್ ಎಮ್ ಥ್ರೂ ಆರ್ ಎಲ್ ಟು ಎನ್ ಇಂದ ವಾಪಸ್ ನ್ಯೂಟ್ರಲ್ಗೆ. So the current is flowing in this direction. So the entire negative half cycle is appearing across the load. But in both the cases ಅಂತಂದ್ರೆ for both positive half cycle as well as negative half cycles of the input side, the current is flowing from M to N only. The RL nalli load, the RL is nothing but the load resistor. Through RL the current is flowing in the same direction in both of the half cycles. ಹಾಗಾಗಿ ನನಗೆ ಔಟ್ಪುಟ್ ನಲ್ಲಿ the waveform will be like this. ಈ ತರ waveforms ಬರುತ್ತೆ. Suppose we want the negative DC cycles ಅಂತ ಹೇಳಿದಾಗ both the diodes D1 and D2s must be connected in the reverse direction. ಆವಾಗ ನಮಗೆ negative DC signals ಬರುತ್ತೆ. So this is the center tapped full wave rectifier. Now let us see another type of full wave rectifier, that is the bridge rectifier. So this bridge rectifier is also one of the types of full wave rectifier. Here we are going to use 4 diodes, whereas in the center tapped full wave rectifier we were using only 2 diodes. In half wave rectifier we were using only 1 diode, whereas here in this rectifier circuit, that is bridge rectifier, we will be using 4 diodes, D1, D2, D3 and D4. And here we are not going to use the center tap transformer. Again we will be using a load RL as well as a transformer, single transformer. So let us try to understand the circuit in terms of half cycles. Let us consider that only positive half cycle is appearing across the input side and ಹೇಳಿದಾಗ this A side will be positive and B side will be negative. A is connected to D1 and B is connected to D2 and D3. ಹೌದಾ? So when A terminal is positive and B terminal is negative, the diodes which will be conducting is D1 for the anode terminal, this will be positive whereas this will be negative. Whereas for D4, here it will be negative, this side it will be positive. B is negative ಆಗಿರೋದ್ರಿಂದ D2 ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಇರುತ್ತೆ, ಇದು ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. D3 ಗೆ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. ಹೌದಾ? So now which are the diodes is conducting when A is positive ಅಂತ ಹೇಳಿದಾಗ, that is when a positive half cycle is appearing ಅಂತ ಹೇಳಿದಾಗ, from A to D1, D1 ಇಂದ ಈ direction ಗೆ ಬರಲ್ಲ, that is through D2 it cannot flow because D2 is reverse biased. Now in this case D1 is forward biased and D3 is reverse biased for the positive half cycle. So current ಹೇಗೆ flow ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ from A through D1 to M through RL to N, then D3 back to B in this direction. So the current is flowing from M to N, from top to bottom direction. Now let us see the negative half cycle. Negative half cycle ಅಂತ ಹೇಳಿದಾಗ the terminal A will be negative whereas the terminal B will be positive. Terminal B positive ಅಂತ ಹೇಳಿದಾಗ D2 will be forward biased and the other diode which is forward biased is D4. D2 ಮತ್ತೆ D4 forward bias ಆಗುತ್ತೆ. D2 D4 forward bias ಆದಾಗ current ಹೇಗೆ flow ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ B to D2, D2 ಇಂದ M, M ಇಂದ through RL to N, N ಇಂದ ಬಂದು ಅದಾದ್ಮೇಲೆ D4, D4 ಇಂದ ವಾಪಸ್ A ಗೆ ಹೋಗುತ್ತೆ. Why it is not taking the D3 path? Because D3 is reverse bias. So the diodes which are reverse bias, they will be acting like an open switch, and the diodes which are forward bias, they will be acting like a closed switch. So we'll be getting the entire cycles, half cycles, that is both the positive as well as the negative half cycles of the input AC signal will be appearing across the load. In both the cases, that is in both during both positive as well as negative half cycle, current is flowing from M to N ಆಗಿರೋದ್ರಿಂದ I'll be getting the waveforms in this manner. Both the positive as well as negative half cycle will be appearing across the load in the positive direction itself. So positive DC cycles appear agide across the load. So this is this bridge rectifier. So rectifier ಅಂತ ಹೇಳಿದ್ರೆ rectifier is nothing but a circuit which converts AC voltage or the current into pulsating DC voltage or current. Pulsating ಅಂತ ಹೇಳಿದ್ರೆ it is nothing but it is in this form. I am not getting a continuous straight line. So ಇದು ಗ್ರಾಫ್ ಅಂತ ತಗೊಂಡಾಗ ಈ ತರ ಕಂಟಿನ್ಯೂಸ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಸಿಗ್ತಲ್ಲ, we are getting a pulsating DC signals. So definition ಅಲ್ಲೇ you have to define like this. Rectifier is nothing but a circuit which converts AC voltage or current into pulsating DC voltage or current. I hope this session was helpful for you. In my next session, I'll be coming with a new topic. Thank you.